All right. So we're coming into this statistics with kind of a vague idea of what statistics is, and we kind of think of it as a subject, but there's actually nouns of statistics that represent different things. But the first thing that we want to start off with is a population. So when I say a population, what do people, you think of when they hear population? Usually get the same answer. I know now that we're recorded, it might be a little different. People. Almost always, people, that's the answer. I think of people when I think of that. Maybe everybody in the United States or everybody in the world. But a population can be whatever we define it. Okay? And I'll put the definition on the next slide. But when we're talking about a population, when we're talking about a population, we can define it however we want. So if we were talking about social networking and influence on American students, well, we would have to study the habits of American students. We couldn't look at European students. We couldn't look at adults. So we would have, as long as we define it a certain way, those are the people that we have to look at. Now, it doesn't have, our population doesn't have to be people, but when we're talking about a population, and in math class, there's a tendency to say, if you have a problem and you have, say, the first 3 lines, and then you have a chart of information, we tend to read that problem like, words, 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 let's get to what the problem is. But in statistics, things like the population or the implied population are in those intros, and every problem that we do is going to be a word problem. So those are important parts of every problem. And again, we're kind of in our past life in the algebra world and pre-calc world, that little introduction didn't mean a lot. It's going to mean a lot in all the problems that we do. Okay, so statistics is collecting, analyzing, displaying data. Okay, so data and information are essentially synonyms, and so there are 2 types of data. Okay, so we've got is that what I want to do? That's what I want to do. That's what I want. Okay, so 2 types. We've got numerical data and we've got categorical data. Okay? And the numerical or quantitative is split up into 2 groups. There's continuous quantitative data and there's discrete quantitative data. Take a second to write that down. Okay, so for quantitative data, there's 2 things. When you're asking a question or finding out information about a person or a thing, is that answer going to be expressed with a number or not? So that's kind of the first thing, and then an average of these numbers makes sense. And so I'll start off with, let's say we were interested in the average height of Madison students. And so we're going out and we're going to sample 50 people, and we're going to measure their heights. So the first question is, would the answer to the question, how tall are you, would that be answered with a number? Yes? No? Yes. We would say 5'10", or more likely, if we're doing analysis, 70 inches. Okay? then the second question is, okay, if we asked these 50 people and we got heights from all of them, and we took the average, and average and mean for our purposes are synonyms, would that average make sense to say, okay, the average height is whatever we get from that, 5'9"? Does that make sense to average it? It does. And so that's telling me that's quantitative data. Okay? So answer expressed with a number and the average makes some kind of sense. So within this world of, and most of the data that we work with is quantitative. And so there's two kinds of numerical variables. There's continuous and there's discrete. Okay? And so for continuous, and so let's say we're talking about heights. Let's say we're talking about heights in unit squares. Will be in inches. So someone comes in and they're, I don't know, 4'10". Okay, so that's 58 inches. But would it be possible that someone would be like, if you're measuring with an exact measurer, could be 57.63 inches tall? Is that possible? That is possible. And in fact, probably, there might be no one in the world who is exactly 58 inches tall, because you go to so many decimals, you're not going to have it. And so continuous could be anywhere along this number line. 56.15 or 57.72, anywhere not along the number line, that could be marked, and that would be a valid answer. That's continuous data. And so the data that's continuous is what I think of as time, distance, height, weight. Those are kind of our four biggies for continuous quantitative variables. All right. But even when we take one of these, like with the height, we don't go to 5 decimals when we're talking about how tall we are. We just kind of round it off to the nearest inch. So for the most part, we take the continuous data even and we turn it into something discrete. If I say I'm 5'7", that's close enough. You get the idea for that. Okay. Although in like football program, if you're really 5'10", you're listed at 6'1", and if you weigh 180 pounds, you're listed at about 205. And so that's I don't know, for intimidation purposes, I don't know. But anyways, so for continuous data. But discrete data, I call that tick marks on the number line. And so if I had a, let's see if I make another scale. And I'll start at 0. And I asked a question, how many siblings do you have? Okay. Could I put in 1.7? No. This would be a case where you'd have to answer in a whole number. And so that's discrete data, where you're doing a count of things. Now, if we took our class and we took a census of the class, and we got an average of 1.7, would that make sense? Yeah, you could still have no individual will have 1.7 siblings, but the average of the class could be that. And so that's the difference between continuous and discrete. And so, like I said, which is why I say I describe it as tick marks on the number line. Okay. All right. But and like I said, you can still make an average out of that. It's the average of a set of discrete data. And so the average is what it is. The average is the average. So you can take an average of continuous data, and that's fine, and you can take an average of discrete data, and that's fine as well. The average is the average. The average doesn't. The average never has to be a tick mark on the number. And so that's numerical data. The other type of data that we work with is categorical. Again. So in this case, your answer is usually expressed with words, not numbers. Sometimes it's answered with numbers, and there are special cases of that. And if they do use a number, that average won't mean anything. So in general, again, so if I was interested in the percentage of people who drove to school, who drove American cars, okay? If I asked, do you drive an American car, would you answer that with word or with a number? With a word. Yes or no? Drive an American car or I don't. So that's categorical or qualitative. And so we take counts of those, but we talk in terms of a proportion. So when we talk proportions always have to take on values between 0 and 1. You can't have a negative proportion, and you can't have anything more than 100%, despite what all of our coaches ask for us to give more than 100%. It's impossible. Okay? So to calculate, and so to get that proportion, I would say I asked 100 people, and 72 people said, I drive an American car to school. Number in the group that I'm looking for over the total. The total is my sample size, how many people I asked. That would be the 100, and then 72 yeses. And so I often refer to it as number of successes. And successes can be kind of defined in a number of different ways, but it's basically the number of things that we're looking for out of the number of things that we observe. And so X, your variable, over N, which is your sample size. So one more minute, and then we'll call it. In fact, we'll close this up for now.